All right, we're running on sound, we're running on video. Okay.
Oh my God, I thought this thing was going to be dead by now.
What's that? Oh, it's going. Okay, so on that sheet I gave you, it says, so it's this sheet, 3.4 economics, right? It says, the first thing says, if the cost of manufacturing Q items is C of Q, where Q is the quantity. C of Q is equal to Q cubed, that's weird, sounds like a tongue twister, plus, yeah, Q cubed, plus 20 Q squared, plus 90Q, plus 15, okay? This is the cost. What that means is this. If you were going to produce 10 units, if you wanted to know the cost of producing 10 units, you would plug a 10 in for Q. And then with a calculator, run the calculation and get a number. That would be the total cost that the business incurs for producing 10 units. Okay? The question says, find the marginal cost function. What is marginal cost? What did we say the other day? It's the derivative of cost. It is the incremental cost for the incremental production, producing one more unit. It's how much the cost goes up by when you produce one more unit. Okay? It's a rate of change, the rate of change in cost. So C prime of Q, which we can call MC, all right, not, yeah, that's right, not, marginal cost, not master of ceremonies. That's what an MC is. You know, the guy with the mic at a, you know, okay. So, yeah. Marginal cost is C prime Q, which is 3Q squared plus, 40. 3Q squared plus 40Q plus 90. So that's the marginal cost. That's the rate of change in the cost. And so if, oftentimes people ask the question, how do we minimize our cost? Okay? Yeah, you can set the derivative equal to 0 and find out what the quantity is to give you a minimum cost. And because this particular one is a quadratic that opens upward, there is a minimum cost, a quantity that will give you a minimum cost. Now, hang on one second. I'm going to warn you that minimum cost should not be your goal when you're in business. But some people do that anyway. Just kind of a side note. Minimum cost is not the best place to be producing. But some people want to know. Why not? Because if you're a business, if your whole, what's that? Well, it might be what you just said. In business, your goal to spend as little money as possible? No. Well, it can help you, but what is your real goal? To make as much money as possible, to make your profit maximum. The goal is not to minimize cost, the goal is to maximize profit. Usually, profit maximization does not occur at minimum cost. Usually. Okay? So that's something very important to consider. So when companies focus on minimizing their costs, they're gonna fail. I mean, they're not going to do as well as they could do because they're focusing on the wrong thing. Don't focus on cost. Focus on profit. Okay? But still, understanding the rate of change in cost is important because we want to know, hey, if we go to 11, okay, if we produce one more, how is it going to negatively affect us or positively affect it? Or, you know, we just want to know what the effect is going to be. Do I have to go running to the bank and borrow money if we want to produce one more? Because if I do, that could be a good thing. I want to go now. I want to go maybe while the interest rates are low. I don't want to find out 3 weeks later when interest rates have gone up. I want to get the money, try to get the ball rolling now. So there's the marginal cost. And then it says, what is the marginal cost at a quantity of 50? All you got to do is go C prime of 50, and plug in, so you got 3 times 50 squared plus 40 times 50. And I agree, you definitely need a calculator for this. I'm sure some people in the world don't. I came up with 9,590. That's what I can. Good. There you go. So that's the marginal cost. What that means is when you're producing 50 units, if you want to go to 51 units, it will probably cost you about $9,600 for the 51st unit. Okay? Chances are, you know what's going to happen at the 52nd unit? This is actually going to go up because look, we're quadratic here, and we're probably to the right of the minimum. Okay, so chances are the cost of the 52nd item is going to be higher than the cost of the 51st, which is normal for business. Normally, once you get past the point of minimum cost, producing more and more and more, your cost per item goes up and up and up and up, and eventually it becomes prohibitive to produce another. So there you go. Now, the next part of the question says, compare this number with the actual cost of manufacturing the 50th item.
So, so you put, what did he just
Hang on one second. Say that again, Juwan. Right? We would plug 50 into the original. That would give us the total cost for producing 50. Not divided, but that would give us the average cost. We don't want the average cost. We want the actual cost of the 50th item. We need one more.
49.
49. That's right. Plug 50 in, then plug 49 in, and subtract. Yep. And then that will give you the actual cost of the. That's what yeah. And I gave you that hint because I figured it's intuitive to some people, but not intuitive to most people. Okay, so I said the actual cost is equal to C of 50 minus C of 49. So for C of 50, C of 50 minus C of 49, this is the total cost for 49, this is the total cost for 50. If we subtract away the total cost for 49, it gives us just the cost of the 50th item. For C of 50, I got the original function, the total cost function. Yep. Sometimes this is called the total cost function, not just the cost function. Okay. But marginal cost is generally based on what we call variable cost. This number over here, this plus 15, Joseph, this is for you. That generally is considered to be the fixed cost. It's the cost that exists even when quantity equals 0. That's correct. It's what we have to pay out even if we don't make anything. That usually includes rent, electricity, a receptionist, because receptionists don't produce anything. They answer the phones and file and stuff, right? Okay? But you got to have one. And if you don't even produce anything, you still got to pay that person. You got to pay your rent, you got to pay your electricity. Those are fixed costs. You pay them even if your quantity is 0. Okay? What's that? Or steal somebody else's electricity. I guarantee you it has I guarantee you it has happened in business at some point or another, and it was probably a construction person that did it. Just guessing. You know, and he's got his warehouse, his electricity got turned off, so he found an outlet that belonged to a neighbor and plugged an extension cord into it. Yeah. Okay, now for C of 50, I got 179,515, and then for C of 49, I got 170,094. And when you subtract this with a calculator, you get 9,421. So the actual marginal cost for the 50th item is 9,421. But the calculus version of the marginal cost is 9,590. Now what you could also do is you could also compare this to C of 51 minus C of 50. Okay? Chances are this number is going to be larger than 9,590. And you'll note that the calculus answer is between the two of them. Okay? But when you're doing this sort of thing in business, it's all really approximation anyway. You're given a guess. What would you say that the marginal cost was approximately?
9,600.
Yeah, you can say 9,600, but based on this one down here, you might say 9,500. You know, if you're a finance guy, you're sitting in the room, you say, it'll cost about $9,500. Okay? Or you might just say, it'll be about 10 grand. Okay? Because, typically when you borrow money, overestimate a little bit.
Well, that's a big difference though, because like if I'm saying you have to pay out 9,600 grand compared to like 9,500 grand, that's a lot. That's a big difference. That's like 100 grand.
No, right. If it's in thousands of dollars, but here's the thing: if you're borrowing this in millions of dollars, actually $100,000 isn't considered to be a lot of money. If you're going to be putting in a loan for $10 million, $100,000, they probably wouldn't fight with you over $100,000. If they were going to tell you you can't, if a bank said, well, we'll loan you $9,900,000, but we won't loan you $10 million. They might say, look, we'll loan you $6 million, but we won't loan you $10 million. Does that make sense?
That's $4 million.
Right. What I'm saying, though, is that $100,000 may seem like a lot of money to us, but when you're dealing in millions of dollars, $100,000 actually isn't that much money. And that's the way businesses generally, larger businesses, that's how they deal. I mean, when you consider that some businesses have, sales in the billions, $100,000 is not much money. Yeah. Okay. But my brain is usually in the theoretical and less in the practical. So that's why I'm telling you that we would just say approximately 9,500 or 9,600. Does this make sense though?
Yes.
Okay. All I'm really going to ask you on the quiz, I'm going to ask you what the marginal cost is, and then I'll ask you what the marginal cost is at a particular point. If the numbers are big, I'll probably let you use a basic calculator. Okay. What's that?
Me too.
Oh, you did? Oh, I am so sorry. Okay. All right. Okay, now let's look at the other main question I'm going to ask you is about maximum profit. Okay. 5 says, let R of Q be revenue and C of Q be the cost. And profit is capital pi of Q equals R of Q, revenue minus cost, right? Yep. And then it says, show that the value of Q that maximizes profit, show that at the value of Q that maximizes profit, marginal revenue equals marginal cost. So, yeah, what is maximum profit? How would we find where maximum profit occurs? Let's say that this is a graph of the profit function.
Something equals 0.
Yeah, when the derivative of profit equals 0, right? It'll give us a slope of 0. So wherever it has a maximum profit, the slope of profit is going to be 0. So what do we need to do to this? Yeah, we need to take the derivative of profit. And by the sum and difference rule, it would be the derivative of profit, pi prime of Q is going to be equal to R prime of Q minus C prime of Q. And what do we call the derivative of total revenue? Marginal revenue, right? And what do we call the derivative of marginal cost? So I'm going to change this to marginal revenue minus marginal cost, and I'm going to change the derivative of profit to marginal profit. Marginal profit. Okay, so marginal profit is equal to marginal revenue minus marginal cost. And now we want to know where marginal profit equals what?
0.
Equals 0. Now, so really we're looking for where marginal revenue minus marginal cost is equal to 0. Algebraically, how can we manipulate this? Add marginal cost to both sides. Add marginal cost, and now we cancel this, and what's left over?
Marginal cost equals.
Yep. Marginal revenue equals. No, you were just saying it backwards. Marginal cost equals marginal revenue, or marginal revenue equals marginal cost. So this will always happen wherever profit is maximized. And it's sort of a shortcut. In economics, oftentimes we don't go through this whole process. We just do the derivative of revenue, do the derivative of cost, set them equal to each other, and solve for Q. That's it. And if we come up with multiple quantities, Guess what we do with them?
Add them.
Not plug. No, we plug them in to the profit function and find out which one has the highest number. That's exactly right. Yep. And that's where we'll produce. And then we can make the most money. Now, you got to understand, this is totally theoretical. Joseph, your parents do not know what their marginal revenue function is. They don't know what their marginal cost function is. However, the concept of marginal revenue is in their head. The concept of marginal cost is in their head. When they're trying to make a decision, they might say, no, we're not going to buy that machine because even though it could make us this much money, it's going to cost us this much, and we're actually not going to make more money, so we're not buying the machine. Okay? But some businesses, they don't think like that. Some businesses, they just say, oh, cool, a new machine, I'm going to go buy it. Not thinking about the fact that it's actually not going to improve their profits at all, although it might make their business more fun. Or cool, that's right. And now, granted, if having the machines brings in more customers because people like the machine, now it's going to earn you a profit because it's going to increase your revenues, okay? But it's amazing. My father-in-law, when he was a dentist, the machinery, much of the machinery that he had in his office was from the 80s. And he was practicing in the 2005, 2004, and a lot of his equipment was from the 80s. They made the equipment so well, it didn't make sense for him to spend $100,000 on a new piece of equipment when he could do the same thing with what he already had that was already paid off. So it didn't make sense for him to buy a whole bunch of new gadgets and stuff because now he would buy, like personally for him, he loves gadgets. So at home, he would buy gadgets for himself. He was like one of the first ones to buy an iMac. He loves that kind of stuff. But at work, he had everything that he needed to be able to do what he had to do. And then sometimes if there was a procedure, like there were procedures that he didn't do that other dentists did, because he said, I don't want to do that. First of all, lots of other dentists are doing it, so why should I do it? Second of all, it's not really going to make me that much more money, and I already have plenty of patients and my time is already booked up, so it doesn't make sense to invest in something that's not going to make my business better. Okay, so there you go. Okay, and then now the second part of this question says, find the profit maximizing quantity and the maximum profit if R of Q is 10Q minus 0.001Q squared and C of Q is 2Q plus 5,000.
So we find the derivative of
Yes,
both of these and
correct.
equal to zero.
Yep. Yes, sir.
So what we just did was our proof.
Proof. We proved that the best way to find maximum profit is by setting marginal revenue and marginal cost equal to each other. And now guess what we're going to do in part B? We are going to set margin. Yeah, we don't have to do the whole thing. We don't have to write out the profit. We don't have to write all that out. All we need is the derivative of revenue, which is 10 minus
2
0.001.
times
0.002 Q equals 2 because the marginal cost is 2Q plus 5,000 and the derivative of that is just 2. Yeah. And now we can just do algebra however you want to do it. I'll do minus 10 here, cancel, and we'll have negative 0.002Q equals negative 8. And now, I don't know if y'all ever do this in your algebra, but I'm like, I got a negative here. This whole thing is negative and this whole thing is negative, so I'm just going to... You're multiplying by negative 1. You're multiplying through by negative 1, so now everything's positive. Okay? I think it is. Maybe that or it's 4,000, I think. Yeah. So now if you divide by 0.002, and by the way, Jasmine, you could just divide by negative 0.002. It's still going to cancel the negative. Either way you look at it. 0.002 and Q, the profit maximizing quantity, winds up being 4,000 units. 4,000 units, by the way, each unit could be 1,000 things. So now your profit maximizing quantity is 4 million. It is very common in business to move the decimal point over because it's easier to calculate things. Like when we talk about the national debt, it's in the trillions, right? Instead of saying 12 trillion, blah, 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 billion, blah, 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 million, blah, 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 thousand, we just say 12.7 trillion or whatever it is. I don't know what it is. I don't keep up with it. I don't want to keep up. Yeah, it's a lot. That's a good word. Yeah, a lot. If it was 12 trillion, 700 and something billion, we would just say 12.7 trillion because it's easier to manage 12.7 than it is to write down this number that has all these commas in it. Okay, that makes sense? All right, so 4,000 units, and now we want to know what our maximum profit is. So you're going to plug 4,000 into the original, which is revenue, 10 times 4,000 minus 0.001 4,000 squared. This is revenue. Am I going too fast?
No.
Minus cost is 2Q minus 2 times 4,000. Now, here's the thing, though. We have to distribute the negative, right? We're subtracting cost, so it's going to be minus 5,000. Minus 5,000. And if you plug all that in, basically what we have here is this is R of 4,000 minus C of 4,000. That's what we're looking at here. And I came up with $11,000 or whatever. I don't know. $11,000. I don't know what it is. Or whatever. It could be euros. It could be yen. Okay. What's that, rupees? He does everything in rupees? Well, in Peru, they would do it in nuevos soles. And in Ghana, they would do it in cedis. That's the name of the currency in Ghana, cedis. And then in Peru, it's nuevos soles. It might not be that anymore. It's been a long time since I've been there. It's been almost 20 years since I've been to Peru. So they might have changed. I mean, the fact that they had nuevos soles, that means, new soles, which means before the nuevos soles was just probably soles. Yeah. So now they might have brand new, newer soles. I don't know. All right. Okay, we're okay with this then? Did anybody else come up with 11,000? Did I do it wrong? I might have done it wrong. All right, I'll check it out. I see, man. I was telling my B2 class, when I make mistakes, I usually make them in front of groups of people. Yeah, I don't make my mistakes in private. I make my mistakes in front of people. And on video, on the internet, it's even better. Yeah. But whatever the number is, I am way more concerned with you understanding the concept than I am in you getting the actual number. The business you own or the business that you work for, they're going to be more concerned with you getting the actual number. Okay, so on the quiz for economics, all you're really going to have to be able to do is identify marginal cost, identify marginal revenue, be able to identify maximum profit, and identify the profit maximizing quantity. Okay? We got about, looks like 20-something minutes to cover today's lesson. Yes. Yeah.
Can we do 27? You told me to bring it up.
Yes. How about this? Can I do 27 on a video? The reason I'm asking is I must cover this, and I think 20 minutes might not even be enough time to cover it.
All right.
Okay? It's not too bad, but you're going to write a lot, okay? You're going to write a lot. Okay? What we're going to talk about today is the derivative. And please, guys, don't pack up until about 20 seconds before 9:40 because we got to get through all of this. We are going to identify. I'm going to show you. These are going to be the hard ones, and then from here down, it's going to become super easy. From here down, we're just going to use the quotient rule. Okay? Because all tangent is sine over cosine, right? Cotangent is cosine over sine. Secant is 1 over cosine, and cosecant is 1 over sine, right? So once we have the derivative of sine and cosine, at that point, all we need to do is just use the quotient rule to get the rest of them, okay? And then at the very end, I'm going to give you a mnemonic that will help you remember the derivatives of these four, okay? So here we go. The way we identify a derivative analytically is with the limit definition of the derivative, right? So we would have to do the limit as h approaches 0 of f of x plus h minus f of x over h. So if f of x equals sine of x, this would give us the what? The derivative of sine of x. Now, some of you guys already know what the derivative of sine of x is because we talked about it. It's cosine, right? But we're going to show why that is true. And there's something that we have to remember in order to show this. And that is, do you guys remember that the limit of sine of x over x as x approaches 0 equals 1, right? That is going to be inside of our analytical solution here. Okay? So here we go. Let's set it up. We're going to have the limit as h approaches 0 of sine of x plus h minus sine of x over h. Notice all I did was plug x of h in for x here. Is we okay with that? So this would give us the derivative of sine of x. Now, there is a trigonometric identity that says this, watch, that sine of x plus, or sine of a plus b is equal to sine of a times cosine of b plus sine of b times cosine of a. That's right. So what we're going to have here is we're going to have sine of x times cosine of h, right? Plus sine of h times cosine of x minus sine of x all over h. And it's the limit as h approaches 0. This is the hardest part right here. Once we get through this one, cosine will be a breeze, and then the rest of them will be a breeze too. Now, well, not yet. It can't, because here sine of x is being multiplied by cosine. So we can't cancel sine of x and minus. See, that would happen in a polynomial, but it's not going to happen here. Watch what we're going to do here. Watch this. I am going to do this. I'm going to get rid of this, and I'm going to put, well, just watch. It'll make sense in a second. I'm going to put a plus here, and I'm going to put an h right here. I'm just splitting up the fraction. We have a common denominator, right? We have a common denominator, so isn't this now true?
Well, you separated the sign.
Yeah, all I did was, yeah, because isn't this plus this, can't we just make it one numerator with a common denominator? Okay. Now, I'm going to write the next one out. I know that I erased, and I'm going to write the next one out so that you can see the comparison. What I'm going to do is this. I'm going to take cosine of h out of the numerator. Okay? And what we're actually going to have is sine of x over h times cosine of h. Is this still the same thing as this piece, this expression? If I multiplied this fraction times cosine of h, can I put this over 1 and then put cosine in the numerator?
Wait, I don't know.
All right. All right. 4 times 5 over 2 is the same thing as 4 over 2 times 5. Right? So you can take any factor out of the numerator and multiply it by the whole fraction. That's the same thing. 1/2 of x is the same thing as x over 2. Right? So all I did was algebraically, I just took cosine out of the numerator. It's still the same expression. It's still equivalent. By the way, I'm going to do it again on the next one. And I'm going to leave sine of h over h times cosine of x. You see what's happening? Yeah. Minus sine of x over h. Now, this is going to be a little hazy because we're going to do things kind of not in a perfect math. I'm not a math person, I'm an economist. We like to sum up things the way that they actually happen, the way they would ultimately happen. So I'm probably going to get criticized till the cows come home over this, but I'm going to do it anyways. I'm going to do some of the limits. I'm going to do one of the limits in here, because it's going to work out that way anyways. Isn't there a product rule of limits that says that this is basically the same thing as the limit of this times the limit of this? What is the limit of cosine of h as h approaches 0? It's 1, right? Because we plug 0 in here, right? So this is basically 1, right? Right?
Oh, because it's that times.
Yeah. Yeah, because this times 1 is just that. And now we have a sine of x over h minus a sine of x over h. So those can cancel out. And all we have left now is the limit as h approaches 0 of sine of h over h times cosine of x. Now, ignore this one for a minute. What is the limit of h, the limit of sine of h over h as h approaches 0?
1.
It's 1. We saw, there's the video proof, where we saw where they used the unit circle and they had the area as a beautiful proof of this limit, right? So if this equals 1, and there is no h over here, cosine of x. Isn't that awesome? So this becomes 1, and if there's no h to plug in over here, so the whole thing, the answer is the cosine of x. Yeah.
You said as h approaches 0, so sine is going to be 1.
This sine of h over h is going to be 1
1 over 0.
because of the proof.
That's what I was thinking.
No. You're forgetting we have a proof for this.
Oh, well, so
We just accept as truth based on a proof. It's a theorem of sorts that the limit. Look.
You're just treating h.
Yeah, we're treating h like an x. It doesn't matter what the variable is. It could be the limit as swirly approaches 0 of sine of swirly over swirly. It doesn't matter what the letter is. Yeah. Okay. So this is 1. And now, if we had split it up into 2 limits, this would be the limit as h approaches 0 of cosine of x. There's no h here to plug it into. What is the limit as x approaches 5 of 19? 19. If there's nothing to plug it into, that's your answer to the limit. So the answer is cosine of x. Is that okay? All right, but you know what? You don't have to do that. And I'm not going to make you do that. All you have to know is that the derivative of sine is cosine. And we just proved it. I just wanted you to see the proof. By the way, this proof is in the textbook.
Okay. No.
So, okay, now let's do cosine. Now let's do cosine. All right? So this is going to be cosine of x, excuse me, and this is going to be cosine of x plus h. All right? Now, we're going to do the same thing. There's an identity for cosine of x plus h. It's a little bit like that other one, okay? But it's the opposite. Instead of doing plus, we're going to do minus, okay? So it's going to be, oh wait, hang on a second. And I think it's cosine cosine minus sine sine. Anybody remember that? Should I go look? Yeah, let's go look. Those of you watching on the video, I'm showing my embarrassment as an economics person, not actually a math person. Let's get a trigonometry textbook here. And we'll go to our identities, our sum identities. Here we go, sum identities in the back maybe. Here we go. All right, sum to product. Or no, that's not what I want. Oh, here it is, sum and difference formulas. Cosine of u plus v is equal to cosine u cosine v minus sine u sine v. There we go. So here's what it's going to become. The limit as h approaches 0 of cosine of x times cosine of h minus sine of x times sine of h minus cosine of x, right? All over h. Now I'm going to do what I did before where I split it up into 3 different fractions. You see it? Okay, so this, make that a minus over h, okay, minus or h. There we go. And now, again, I'm going to take cosine of h out of the numerator. Oh wait, I'm leaving it, that one. Cosine of, yeah, I'm taking cosine of h out of the numerator. Okay, so now it's cosine of x over h, and cosine of h is sitting next to it. Cosine of h. Just doing a little bit of algebra here. Here, I'm going to leave the h with the sine of h. You know why? That one's going to cancel because of our limit of as x approaches 0. And we're going to put sine of x all by itself right here. Sine of x by itself. And now, what is the limit of as h approaches 0 of cosine of h? 1, because we plug 0 in here, cosine of 0 is 1. So this is basically 1, that cancels. And now we have cosine of x over h minus cosine of x over h. What happens to those? They cancel each other. And now all we have left is the limit as h approaches 0 of negative sine of x times sine of h over h. And now, we can call that one thing and this something else being multiplied by each other. Split it up into 2 limits. Say that again. This is going to equal 1. And what's the final answer? Negative sine of x. So the derivative of cosine is negative sine of x. Okay. And now, okay, all right. All right.
I mean the bottom part.
Bottom part. All right. So up here, I'm going to... Oh, I'm sorry, I forgot, man. All right, well, you got the video, right? Watch the end of the video. Go ahead and take off. All right, now, to do the rest of the derivatives, we're just going to use the quotient rule. In fact, I'll just do all 4 of them on the board. Here we go. We're going to do the derivative of tangent. Okay? So d dx of tan x. Okay, tangent is sine over cosine. Okay? So d dx, yes, sir. Oh, thank you. I appreciate it. D dx of sine over cosine is going to be derivative of the top, cosine, times the bottom, cosine, minus the top, sine, times the, you two, man, times the derivative of the bottom, which is negative sine. And since it's negative sine, it's actually going to change that right there. So sine all over cosine squared. And we say that's how we write cosine squared. And technically, look what we have up top. This is actually cosine squared. And this here is sine squared. Okay, that's right. What's that? We're getting there. Now we're going to turn this into 2 fractions. Cosine squared of x over cosine squared of x. Oh, wait, yes, I'm sorry. I know what you're saying. You're telling me that, yes, that's an identity. Cosine squared plus sine squared is 1. It's an identity. So what we have is 1 over cosine squared, and cosine is secant. So what we actually have here is secant squared. So the derivative of tangent, very simply, is secant squared. Now we'll do d dx of secant. I don't know if we're going to have time to get through all of them. If we don't, then I'm just going to give them to you. Okay, so this is going to be d dx of 1 over cosine. Okay? So, of 1 over cosine. So we're going to do derivative of the top, 0, times the bottom, cosine of x, minus the top, 1, times the derivative of the bottom, negative sine. So we'll make this plus sine, all over cosine squared. Okay?
So it's just
And
zero.
what's 0 times cosine?
0.
That's 0. That cancels. So really all we have is sine of x over cosine squared of x. And if we split that up, it's going to be sine of x over cosine of x times 1 over cosine of x.
Okay.
Tangent times secant.
Wow. Okay.
So the derivative of secant is tangent secant. We don't have time.
Where'd you get 0 from? 0.
0, the derivative of the top, times the bottom. This is what I would encourage you to do. Don't pack up, because I got to give you the rest of the derivatives and the mnemonic. I would, how is which one what?
Okay, I don't understand because it's not, okay, at cos, like, okay, no, down, right up, there. Okay, it's not, where are you going? It's not squared, so how do you do that identity if the cosines aren't squared on the bottom?
Okay, I'm splitting this up. I have sine of x over cosine squared of x, right?
I understand that.
Okay, and I'm splitting it up. I'm making this.
I know, but how do you simplify it to the identity 1 over cosine x when it's not cosine squared x?
Secant isn't 1 over cosine squared, yeah. This is 2 of them. That's why we did secant squared.
Okay,
Yeah.
I'm really confused.
Yeah, it's all right.
I can't do this and write and not look at it because I'm like,
I would watch the video a little later,
okay.
maybe by tomorrow or something. Listen, we don't have time, but I still want to give you the answers. We don't have time to do these two. I recommend you do these proofs at home or find them on the internet. But let me give you the answers. The derivative of cosecant of x is negative cosecant cotangent. Negative cosecant cotangent. The derivative of cotangent is negative cosecant squared. And I'm going to show you a mnemonic that will help you remember this. Okay? All right, so you're sitting in the AP exam. You're trying to remember the derivative of secant, right? And you can't remember. So you lean over, you see one of you guys is, you're trying to think, and Jasmine is sitting right next to you. And you're like, nobody's looking. Jasmine, psst. Psst. Yeah, don't do that. Don't really do that. Psst. Okay? This is what you would do, right? Psst. Hey, what's the derivative of secant, right? No, you don't really do that, okay? But look, so think PSST, but get rid of the P. The P is irrelevant. Okay? And now, S is secant. The other S is also secant. The T is tangent. Underneath, right there, co-functions. Cosecant, cosecant, cotangent. So far, so good? If you want the derivative of tangent, it's secant times secant. If you want the derivative of secant, it's secant times tangent. We're going to put a negative right here. If you want the derivative of cotangent, it's negative cosecant cosecant. And if you want the derivative of cosecant, it's negative cosecant cotangent. Yeah. Does that make sense? Now, I also want you to notice, please, one more thing. Is this a co-function?
No.
Its derivative is positive. Is this a co-function? No, tangent. No, its derivative is positive. Is this a co-function? No, that's secant. Not a co-function. They start with co. Its derivative is positive. But look at all of the co-functions. All of their derivatives are negative. All co-functions have a negative derivative or an opposite derivative. Yeah, well, please watch the video. Yeah, give me a second. I got to hit stop on this.